Hello, a very good morning to all of you. So we are going to continue from where we stopped previously. So we are going to start a brand new chapter, which is about haloalkane for semester 3. With that session, let's have a look together about the content. Okay, so we are going to discuss the objective question for chapter 4. So let's begin. Methylbenzene react with chlorine in the presence of light to produce XC7H7Cl. X hydrolyzed by aqueous sodium hydroxide to produce compound Y. Which of the following is true? So you must know by yourself in here that when chlorine can undergo hydrolysis, so this chlorine is impossible to attach to the benzene. It must be attached to this alkyl part inside the methylbenzene. So that is why you have to know. So saying that it forms a benzoic acid when oxidized, which is true because it can be oxidized. Okay, it is neutral. It is also it is not correct because it's slightly acidic, and it gives violet color when react with aqueous iron trichloride because it can react with the product form can be reacted with this iron trichloride in here. It is one of the chemical tests to test the presence of the phenylmethanol. And it reacts with phosphorus pentachloride to form back X, which is also correct. So in here, the best answer in here is 1, 3, and 4. So your answer is C. For number 2, mechanism of a particular reaction is given below. So that is the described mechanism. Okay, which of the following are correct regarding of the reaction above? So you can see from here that it is only forming this intermediate. So this is basically an SN2 mechanism. So it is a substitution reaction. Yes, it is because you substitute out the bromine out. So it is true. Okay, so the alcohol form is optical active. As you can see, it is formed by it is surrounded by different alkyl groups, so it is optically active, which is also true. OH minus act as a nucleophilic reagent, which is also true because OH minus attack the center carbon, and the mechanism is SN1 since it's a tertiary alkane, which is not true because from the mechanism you can tell that it is an SN2 mechanism. So the best answer in here is 1, 2, and 3. Number 3, which of the following pairs of compound react with nucleophilic substitution reaction? So the products given for each of the reactions in here you must understand very well. So this one will result the formations of a nitrobenzene, chloronitrobenzene, which is at the auto and para position. Whereas at B also the same. It is also an electrophilic aromatic substitution reaction, where it is also substituting at the auto para position. As for C in here, when you react with concentrated this sodium hydroxide, it can still undergo a nucleophilic substitution reaction, but you require a very extreme condition, which is high temperature, high pressure. However, in here, it doesn't really state that, so C might be the answer, and then D, concentrated NH3 ethanol is maybe also correct, but because ammonia is a very weak nucleophile, so it is kind of impossible for the substitution of the chlorobenzene. So that is why D is not the best answer compared to C. So in here, C is still the best answer in here. Number 4, a liquid P decolorized bromine water and form a white precipitate with aqueous silver nitrate. So P could be what? So in here, you can, since it says that it decolorized bromine water, it may be two possibility. Either you have a unsaturated hydrocarbon, or you might even have this what we so call as this phenol. Okay, phenol can also decolorize the bromine water and then form a white precipitate with aqueous silver nitrate. Means that the chlorine here is not attached directly to a benzene ring, so it is attached to an alkyl part, because when chlorine is attached to a benzene ring, it is very hard for the chlorine to be hydrolyzed in here, so that it's impossible to form to undergo hydrolysis. Okay, so in here, number 1 is correct because you can also form a benzene, react with bromine and undergoes nucleophilic substitution. Same goes with number 2. 2 can also react. Whereas number 3, because you don't have a C double bond C, even though you have a benzene, but you don't have a C double bond C, so C cannot react. And number 4 also cannot react because of the same thing. So the best answer in here is 1 and 2 only correct. So the answer is A. As for number 5, an amine is produced in the 2 steps reactions shown in below. So I have 2-bromobutane KCN ethanol, and then you have X, and then you have LiLH4. So the whole mechanism in here I can show you from the flow chart in here. So first, when you react with tro-bromobutane, so this is how 2-bromobutane looks like. When you react with KCN in ethanol under reflux, you form a cyano compound. Okay, so when you react with cyano compound undergo hydrolysis, reduction reaction, you form a primary amine in here. So in here, the name of this is 4 carbon 1, 2, 3, 4. So it is butane 1 amine. Butane 1 amine, and you have a 2-methyl in here. So the full name is 2-methyl butane 1 amine. So the best answer in here is A. Number 6, when chlorine gas is bubbled through methyl benzene under certain condition, the compound MC7H7Cl is produced. Compound M form white precipitate with warming ethanolic silver nitrate. Which of the following could be M and suitable condition for the reaction for compound to react? So in here you can see that when you can react with warming ethanolic silver nitrate, that means that this chlorine is not attached directly to a benzene ring. Instead, it is directly attached to an LQ chain in here. So if you want to form a chloromethylbenzene in here, so it must undergo a free radical substitution reaction. So the condition of the chlorine in here is undergoes under ultraviolet condition, and the chlorine here is not attached directly to a benzene ring. So the whole description in here is trying to tell you that the best answer in here is B. So that is for number 6. Whereas for number 7, table below shows the boiling point of some haloalkane. So this is the boiling point. As you can see in here, they are using different halogen. Different halogen give different molecular mass. So this will give different van der Waals forces, hence different boiling points. So this is due to the molecular size increase from CH3CH2Cl, CH3CH2Br, and CH3CH2I. So the best answer in here is C. Number 8, which one of the following pair of reagent can be used to prepare chloroethane? So you have a CH3CH2Cl. So the best way to prepare, can you prepare from number 1? Yes, you can via electrophilic addition reaction of the hydrogen chloride. You can form chloroethane. And then number 2, you can when you react this alcohol with chlorine. So now it cannot form because chlorine cannot directly react with alcohol. So number 2 is wrong. Whereas number 3, hydrogenation of a chloroethene. So chloroethane, when it undergoes hydrogenation, you still can react. So 3 is correct. And then number 4, you react with a thionyl chloride, which is also substitutable. So the best answer in here is 1, 3, and 4. Whereas number 9, which of the molecule structure below we have the smallest overall dipole? So you must in here, you must have a condition where the chlorine can cancel off between the dipole forces in here, they can cancel off each other, the bonding, and the dipole polar bonding, they can cancel off each other. So in here, it seems that the best structure which can cancel off the dipole among each other in here is D. Okay, so that is why it has the smallest overall dipole moment in here. Number 10. When you have these structures here, put 2 in, react with X, you form 2-bromobutane. When you react with Y, you form butan 2O. So which of the following pair could be X and Y? So in here, you are undergoing addition reaction of HBr. So in here, the first one for X is probably HBr. But then in here, you undergo nucleophilic substitution reactions, where probably the best in here is sodium hydroxide. So the best answer in here is B. Okay, so as I mentioned just now, X in here is electrophilic addition reaction, while the Y is nucleophilic substitution. So the answer is also B. Whereas for number 12, a halogen compound W has boiled under reflux for some time with ethanolic silver nitrate, little or no precipitate with sin. Which of the following formula could be W? So in here, if you don't want to see any precipitate when react with ethanolic silver nitrate, so chlorine attached directly to the benzene ring is the most significant in here, because chlorine cannot be simply removed from a chlorobenzene. Therefore, it is hard to see the white precipitate. Okay, so therefore, the best answer in here is B. Number 13, chloroethane is converted to ethanoic acid through a 2-stage reaction. Which of the following could be the intermediate of the ethanoic acid? If you look carefully in the questions in here, from ethane to ethanoic acid, there is no increase in the number of carbon. So when there is no increase in the number of carbon, so the 2C will remain. So which one is the best intermediate of the reaction? The best intermediate reaction is shown in the flow chart in here. So first you form chloroethane to become ethanol, and ethanol when you oxidize you become ethanoic acid. So the best answer in here is A. Number 14, which of the following compound could be prepared by reacting bromoethane with potassium cyanide and then form other product? So in here, when you react with bromoethane, you form a propyl nitrile. When you form a propyl nitrile, it can either ends up to become a propanoic acid or it became a propane amine. So the best answer in here is number 1 and also number 4. So the best answer in here is boy. Number 15, any compound is formed by reacting to the following reaction. Okay, so you react with bromobutane, 2-bromobutane. When you react with step 1 by X, when you react with step 2, you form this one. If you notice the beginning to the end, you may notice that there is an additional increase of 1 number of carbon. So when there is additional of 1 number of carbon, the culprit behind that is definitely a potassium cyanide. So you must form a nitrile first and reduce to become the desired product in here. So in here, the best answer is C. So that is for number 15. As for number 16, an amine is prepared by the following reaction. You have iodoethane react with ammonia to form ethanamine. So in here, it is obviously a nucleophilic substitution reactions. Yeah. So the answer is donkey D. Very straightforward questions. Number 17, it is estimated for every chlorine atoms from a chloroalkane in the stratosphere, 100,000 of ozone may be destroyed. Which of the following statement provides an explanation for this? So the reason why this CFC is toxic, is harmful to the environment, it is due to the formation of the free chlorine radical, which eventually destroy the ozone layer. So eventually you form a chlorine radical via the ultraviolet. So in here, the best answer in here is they are regenerated in a chain reaction with ozone, where chlorine radicals react continuously with the ozone layer. So the best answer in here is donkey D. Number 18, when the aqueous bromine is added to organic compound Y, bromine color discharge. To which classes could Y belong? So as I mentioned just now, if you notice carefully when you explain number 10 just now, there are two things which can decolorize bromine. Either it is alkene or it is a phenol. So the most obvious answer in here is 1 and 2. So the answer is A. Number 19, reaction scheme below shows the formation from the propan2-ol to form compound Z. So which of the following could be X, Y, and Z? So let's study together in the chart here. As you can notice carefully, so X in here, when you react with OH to form back Cl, it must be a strong chlorinating agent, either a thionyl chloride or phosphorus pentachloride. So A, B, C might be the answer. D is already out. And then if you look carefully at Y, so Y in here, when you react with potassium chromate 7, potassium dichromate 7 is an oxidizing agent. So since it is a secondary alcohol, so you form propanol. Okay, so A is out from our answer. So B and C is our final choice. And when you react with Brignard reagents to a propanol, you form a tertiary alcohol. So in here, since B is a tertiary alcohol, while C is also a tertiary alcohol, however, the C is attached to the middle carbon, not to the end carbon. So when it is attached to the middle carbon, the best answer that you can represent X, Y, and Z is C. So here is a flow chart that already shows you in here. As you can see from the flow chart in here, you can see that this is how the whole reactions goes in here. So this will make the answer in here is C. Okay. Okay, so this is number 19. Then we go to number 20. An organic compound P undergo hydrolysis under atmospheric pressure to form alcohol Q, which is not oxidized by potassium manganate solution. Which of the following could be P and Q? So you must remember that the only alcohol that cannot be oxidized are either phenol or tertiary alcohol. Now, since in here it is impossible to be phenol because the question already stated that P undergo hydrolysis under atmospheric pressure. Chlorine can only react via hydrolysis reaction when you have a high temperature, high pressure. So B is out from our choices. So the best answer in here is C. 21. Which of the following are not suitable to be used as a fire extinguisher? To become a fire extinguisher, you must quickly put off the oxygen first. So to quickly react with the oxygen, either you form a free radical or you try your best to prevent the formation of the burning substance directly react with the oxygen gases. So in here, in order to do that, you must have either halons, okay, where the halogen can easily be removed in here. Okay, so the first one, number one, is possible because it can easily form a bromine radical. Okay, so one is correct. Whereas number two is not possible to become a fire extinguisher because you have a long hydrocarbon chain. So when you have a long hydrocarbon chain, it will support the combustions, hence cannot put off the fires in here. So number two cannot be. Whereas number three, you cannot be used as a fire extinguisher because hydrogen chloride cannot form fluorine-free radical. Same goes with number four. Number four is a non-polar substance, so it cannot form a free radical. So number four also cannot. So the one which is not suitable to become a fire extinguisher is 2, 3, and 4. So the best answer in here is donkey D. 22. Compound X with the molecular formula CnH8Cl produce a compound Y after it reflux with alcoholic sodium hydroxide. Compound Y which react with 1.75 gram of compound X to form and absorb 210 centimeter cube of hydrogen gas at 25 degrees Celsius, 1.1 times 10 power 5 Pascal. Which of the following structure could represent X? So if you can understand the whole question, what is the whole question trying to ask in here is the reaction of Y is reflux under alcoholic sodium hydroxide is to form alkene. So that is why alkene absorb hydrogen to form alkane under this condition. So the purpose of the question is to find out how much actually compound Y that react with the substances occur. So that is why we need to find out how much of the hydrogen absorbed. Then we compare stoichiometrically to the mole in order to find out what is the number of the halogens formed there. Okay, so you use PV equals to nRT. Okay, so 1.1 times 10 power 5 multiplied by 210 times 10 power negative 6 equals to nr times 8.31 times 298. So eventually you find out that the number of mole is 0.00933. So Y absorbs 0.00933 mole of hydrogen. So number of mole of X in here is 1.75 divided by 175, which is the molecular mass. So you get also 0.1. So 0.009, we assume that is approximately equals to 1 mole of hydrogen. Since the number of X to form Y, we absorb 1 mole of hydrogen. So Y can only form 1 mole of the double bond. So if you look carefully at the A, B, C, D here, so A, you have 2 hydrogen and 2 chlorine. You can form a C triple bond C. So same goes with B. So B, when undergoes elimination, you also form a C triple bond C. So A and B is out from our choice. As for C, when you remove this HCl, you can only form 1 C double bond C. Whereas D, you cannot undergo elimination reaction. So the best answer in here will be C. So that is for question number 22. Number 23, which compound react with methyl lithium to produce 2-methyl-2-butanol? So 2-methyl-2-butanol, if you know how to draw out the structure, it is a tertiary alcohol. So when it is a tertiary alcohol, what react with a Grignard reagent? You react with a propanone, okay, in here. So best answer in here is donkey D. 24, which of the following true regards to both haloalkane CCl4 and CFCl3, okay? Okay, number one, compound which does not hydrolyze, which is not true because CCl4 cannot hydrolyze, but CFCl3 can still hydrolyze. So one is wrong. Number two, polar organic compound. CCl4 is non-polar, CFCl3 is slightly polar. Number three, greenhouse gases, which is true because both in here form type of the greenhouse gases, which is toxic, and both four are volatile, therefore a low boiling point. So number one and number four are the best answer here. Okay, so that is for number 24. Then 25, butyllithium with molecular formula C4H9ClI is very useful in organic compound in synthesis. Which statement about are true about butyllithium? Number one, it is more reactive with Grignard reagent, which is true because it is more reactive. But that is why to prepare butyllithium require extreme cold condition. Number two, is the starting substance to synthesis silicone, which is also true because you users bring the reagent to form a silicone. It can be used to prevent alcohol, which is true because you can make use of different class different type of the carbonyl compound to form different class of alcohol. And in synthesis, it requires higher temperature compared to Grignard reagent, which is false. As I mentioned just now, it requires colder conditions. Okay, so 1, 2, 3 is correct and makes your answer A. 26. CH3CH2Br react with aqueous sodium potassium hydroxide to form an alcohol, CH3CH2OH, whereas CH3CBr react with ethanolic sodium potassium hydroxide to form an alkene as the major product. Which statement is true about the two reactions? So as you can see, the first reaction is trying to explain a nucleophilic substitution reaction, whereas the second reaction is an elimination reaction. Okay, so which of the following statement is true? Both reactions occur at room temperature, which is not true because you both require reflux. B, reaction occur through the formation of carbocation, which is also not true because in this formation of the ethanol, it is a SN2 reaction. So SN2 reactions form an intermediate, which is a negative charge compound, not a carbocation. So B is wrong. And then number C, the reaction are nucleophilic substitution and elimination respectively. So as I mentioned just now, the first reaction is SN2 nucleophilic substitution in second order, whereas the second one is the elimination. So number 3 is correct. And number 4, rate of reaction is independent with the OH, which is wrong because the first one, nucleophilic substitution reaction, is seriously depending on the concentration of the OH minus since it is an SN2 mechanism. So the best answer in here is C. 27. What is the intermediate species when 2-propanol react with hydrogen chloride gas to produce a 2-chloropropane? So in here, you might even, because it is a secondary haloalkane, so there is a chances for you to undergo SN1 mechanism. So in SN1 mechanism, you probably can form a carbocation. So when you can form a carbocation, the best answer in here will be C. 28. A mixture of chlorobenzene, CCH5Cl, and dichloromethylbenzene, C6H5CHCl2, is heated with an aqueous solution of sodium potassium hydroxide. Which of the following pair compounds are found at the end of the reaction? So you must understand the reactions in here. So CCH5Cl cannot undergo hydrolysis in atmospheric pressure, while hydrolysis of CCH5CHCl2 undergoes hydrolysis. First, you form a diol, where both of the OH is attached to the same C, and when further reacted, you can dehydrate to become benzaldehyde. So the best answer in here is point. 29. When 2 haloalkane T and U are refluxed with aqueous potassium hydroxide separately and W are formed separately, V react with sodium carbonate while W does not. What could U be in here? So in here, if you want to react with sodium carbonate, you must know that V form is a carboxylic acid. And when do you form a carboxylic acid? When you have a trihaloalkane attached at the same carbons in here. So V must contain RCCl3 in order to form RCOOH, while W must contain RCHCl2 or RCHCl. Therefore, the best answer in here will be D. Last but not least, number 30, most of the reaction of haloalkane involve SN2 mechanism. Which haloalkane shows the lowest reaction of SN2 mechanism? So this is basically a substitution reaction. So to substitute, the most difficult to substitute is definitely a chlorobenzene. So this is a very direct question where in here, the best answer in here is donkey D. Okay, so with that, I finished the part for the objective. So we shall continue on our next lesson to discuss the structure questions for this chapter. Okay, so I guess that's all for our lesson today. So see you all next week. Thank you very much.